Okay, so we are here now, right?
Yes, sir.
Can everyone hear me?
Yes, sir.
Okay.
Yes, we can hear you.
Yes,
Awesome.
sir.
Okay, fine. So like I said, this is what immediately you start off. You want to start any new script. Type your install.packages, pacman in inverted commas, and then you do pacman :p_load, and then you put in whatever packages you want to install and load. Now, like I say, for startups, tidyverse is a very good one because tidyverse contains several packages for you. Forecast is not really relevant for you at this early stage, so I wouldn't advocate you to load that. When you get to a stage where you need to use it, you can use it. Rio is a package that helps you import data sets into R. Rio and Here help you do that. Then there's also a package we call Scheme R, which helps you in data exploration. You can notice once you type the package, you put in a comma before you type the next one, a comma, and then when you're done, you close your bracket. So that's it. So this okay, let me add one more. Let's put janitor. Janitor is another package used in table formulation. And let me add a fifth one, GT summary is another package. So these 6 packages should be okay for you in this early phase of data analysis and data management. So you could just have this stored somewhere so that when you're starting any script, you can just run these two commands. First of all, you run install.packages with pacman in quotation and in brackets, and then under it, you do your pacman :p_load, and then you do this. So once you've done this, you're ready to start your data analysis work in R. Okay, let's look at the next thing we're supposed to do. Okay, so it says we should import data into R Studio. Fine. Now, usually, let's assume there's a data I want to import into my R Studio. Let me show us a very easy way. I go to File, I go to Import Dataset, and then depending on what platform in which my dataset is in, I click that. So it could be in a text form, it could be from an Excel, from an Excel spreadsheet, it could be from SPSS, it could be from SAS. So whatever platform in which my dataset is stored, I could take it out from here. So I have datasets from Excel. So I have it stored in an Excel document. So I click from Excel. So now, let me minimize this so we can see this very well. So now, it shows me this box. I go to Browse so I can locate where my dataset is. Now, the dataset I want to import in R is within my Documents folder. Inside my Documents is within a folder I call Cap2. So this is it here, Cap2. I double click it. And then the dataset is this Excel file, which I wrote a cap_fish2. That's where my document, my data is. So I double click it. So it brings me back to this, to that box where I started from. Now, because R desires that we use codes, it's better. I can just click import here and it will import. But it's better to use codes because codes has a more permanent way of storing that data that you have imported. So you can see this place where they wrote code preview. I'll just copy whatever is here, because that's the code I need to import that data set. I'll copy it, Control C, after I select it, and then I'll cancel this box, cancel this. And then I'll come to my source code, and then I'll paste, Control V, paste that code I have copied. And then I'll run these 3 commands. First of all, library read Excel means I want to load this, this package. So I load library read Excel, Control Enter, and then let's look at this second code. This second code says cap_phase2, and then you can see the assignment operator that we talked about, the less than and the minus sign joined together. So what this is saying is that this code says read_Excel, which is the function to import this data set into R. But what R is saying here is that I want you to import this data set, but I want you to assign it to an object called capphase2. So if we had removed this, if we remove this part of the code, this capphase2 and this assign operator, and run this code, it will still import the data set into R. But because we want to create an object that will store that data set, that's why we put in this capphase2 and we put in this assignment operator. So whatever it imports from this code, it will put it into an object called capphase2. And once we run that code, you will see within this environment here, you will see the object called capphase2 has been deposited in the R environment. So I'm just going to run that second code. Did I run it? Control Enter. Okay, so you can see here, it has there's a data set here now that has been assigned to this object called capphase2, and the data set has 715 observations and 188 variables. So that's what this second code has done. This second code here that I highlighted. And now if you also look at the console, you can see that it has also brought in the data set. You can see the code that we ran, this capphase2 assignment operator, and then read_Excel, blah, 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 blah. So these are the contents of that data set. So if we had not put in this capphase2 and assignment operator, all we would have gotten is just what is inside this console. But because we put in this, it also additionally stored the data set in a folder called capphase2, or sorry, in an object called capphase2. Okay, so the third code here, which is view capphase2, will now show us the data set in a tabulated form. So if I run this code, Control Enter, so you can see it's showing us. Let me zoom into that first quadrant. So it's showing us the data set that we have imported in a tabular form. You can see that it's quite a large data set. It has 118 variables, so it's quite a large data set. This is not the kind of data set you will be working with at this early stage. Usually, you have a smaller data set that's manageable. This large volume data sets are for those that have that long-term experience with data management and stuff. But I just wanted to show us an example of how to import a data set in R and then how to view it. Okay. So, sorry, let's go back to that again. So I go back to my 4 quadrants. I go back to this. Okay, so I just want to go over it one more time so that it sticks. To import a data set in R, the very easy method, you go to File, you go to Import Data Set, which is here. And then depending on what platform your data set is stored in, because it's not only Excel. Sometimes you might have a data set in SPSS, which you want to import into R. You might have a data set in SAS, in Stata, or a text data set, which you want to import into R. So whatever platform your data set is in, you can choose from here. So mine is in an Excel file, so I can choose from Excel. And then this dialog box will open up for me. And then I can browse from here to get where my data set is. And mine is inside my document folder. Inside my document folder, it's in a folder I call cap2. So I click on this, and then this cap phase 2 is my Excel file that contains my data set. So I can click it, double click it, and it opens. Now, naturally, you would have just come and click import here, but I discourage that because we want everything to be in codes. You come to this code preview and you just select and copy this code that is written here. You select it and then you do Control-C, that copies it, and then you close this dialog box, say cancel. Then when you come to your R Studio, you copy and you now paste what you have copied, Control-V and paste. And then there are now 3 codes that are there. So you now run each of them individually. So you run library with Excel, and then you run the second one, Control-C, and then Control-Enter, not Control-C, and then you run the last one, which now views the code for you. So that gives you this. If you want to zoom in into that quadrant, you click Control-Shift-1, and it zooms in into that quadrant. If you want to go back to your 4 quadrants, also click Control-Shift-1, and then you go back to your 4 quadrants. So that's how to import a data set in R. Let's look at the next thing we want to do. Blah, 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 blah. Okay, so next thing is to enumerate the steps in a data management process. Awesome. Okay. So once you have done this, you have installed the Pacman package, you have installed and loaded all the packages that you want to work with, you have imported your data set into R. The next thing is to start your data management process. And this, in summary, there are 6 data management steps. And I want you to have these steps at the back of your mind so that even if you're woken up, you can easily tell the steps. Number 1 is, so for those that have watched the video, can you tell me, number 1? I can't hear anybody. Hello.
Data cleaning.
Data cleaning is not number 1.
It's like an overview. You just go through and then
what's
look
the
at
name?
the general.
What's the name of that? What's the name of that step?
It's like it's skimming.
No. Yes, skimming is another name for it, but that's not the name on the video. So
yeah, that's not the name on the video.
Explore. Sorry.
Explore.
Number 2. So let's add data to it. Data exploration. Number 2. What's number 2?
Data cleaning.
Data cleaning. Excellent. Number 3. Data manipulation.
Manipulations.
Number 4.
Experimentation.
Data Description and summarization. Number 5.
Analysis.
Data
analysis.
visualization. Number 6. I
Data
thought
analysis.
I thought you have watched the video.
Data analysis.
Yeah, data analysis. Okay, so these are the 6 broad steps of data management process. Let's go through them again. Number 1, data exploration. Number 2, data cleaning. Number 3, data manipulation. Number 4, data description and summarization. Number 5, data visualization. Number 6, data analysis. So this is what you do to any given data. Once you follow these steps of the data management process, you can never go wrong. And it is good that you observe these steps so that you don't miss out on anything. And whoever is looking at your data management process knows exactly what you're doing and knows that you know what you're doing. So please commit these 6 steps to memory. And once you're doing any data management process, these are what you need to do. No matter the kind of data, this is what you need to do. Okay. So this brings us to the end of our basics. This brings us to the end of the first lesson. That's the first lesson. So we've been able to download and install R and R Studio and appreciate their difference. We've been able to describe the 4 quadrants of R Studio window and appreciate their functions. We've been able to understand the concepts of objects, functions, and packages in R. We've been able to define the characteristics of a tidy data in R. We've been able to identify special operators in R and their functions. We've been able to create an R project, open and save a new R script. We've been able to install packages in R Studio. We've been able to import data into R Studio, and we've been able to enumerate the steps in data management. Okay, small quiz. Can someone tell me what a package in R is? When you see a package, what does a package mean in R?
A package is a collection of functions.
Say it again, sorry.
A package is a collection of functions.
Good. A package is a collection of functions. Very good. Can you name 4 special operators in R and tell me what their function is? Any 4 operators that we've looked at in R and tell me what their functions are.
Arithmetic operator.
Sorry, can someone else try? Abubakar has answered the first question. Can someone else try?
Operators.
Yes.
I think there is less than minus. So that is assign.
That's the assignment operator. So what does it do?
It's more like what it does. It assign variables or numbers to variables.
It assigns a value to an object. Very good. Okay. Object. What other operator?
We have is it
we have type operator.
Imports.
Say it again.
Pipe operator.
Pipe operator.
Piping.
Exactly. Good. So what does the pipe operator do? Hello, can someone hear me?
question. No, it pipes in. Okay.
I think piping leaks.
Pipe operator is used to for want of using another word, to pipe one thing into another, to pipe something from the left-hand side into the right-hand side, to pipe a data set or a data frame into a function, or to pipe, yes, a data set or data frame into a function. So that's, it just takes whatever is on the left-hand side and make it as an object for the next function on the right-hand side you want to apply. Like I said, as we go further, you will begin to see us use the pipe operator very, very often. In fact, the pipe operator is one of the most common operators I use in my analysis. Okay, so what are the characteristics of a tidy data in R?
As columns.
Sorry, say it again.
It has columns.
What has columns?
Contain.
Yes,
okay,
go ahead.
Each
go ahead.
variable.
Good. Each variable has a column. What's the next
column?
What's the next one? Each observation has a row.
Has a row.
And what's the last one?
And then each number has each cell. Each number has a cell.
Each value has a cell.
Each value has a cell.
It's value because it might not be a number in that cell. It might be word. So
word.
Each value has a cell. Okay, so those are the three characteristics of a tidy data in R. Okay, so finally, let's list the 6 steps in data management. So starting with number 1.
Data exploration.
Exploration, good.
Cleaning.
Cleaning, good.
Manipulation.
Manipulation, very good.
Visual description.
You describe and summarize, good.
And summarize. Visualization.
You visualize, and finally,
and then you analyze.
You analyze. Awesome. This is a perfect group. Okay, so in what we have done so far, does anyone have any questions in what we have done so far? Any questions, any comments, any observations before we move into the next?
So I don't know if we have any form of manual that will make us remember some of these languages and how to execute some of these functions.
That's why you have this video. What I want you to do is, after each session, when I send you the video, sit down, as you're watching the video, be replicating exactly what we're doing in the video on your system. Just replicate them on your system. Like that, you're beginning to get familiar with the environment, with the words, with the narratives, and it begins to become second nature to you.
Okay,
so
sir.
Just once you're practicing and practicing, you will get it. I still practice R every day. So there are new things to learn. So just as you keep practicing, you get better and better and better, and then you move to newer levels.
Okay, sir. Thank you.
You're welcome. Any other question, observation, comments?
Nope.
None?
None so far.
So everyone is okay.
Yes, sir.
Yes, sir.
Awesome. So we're going to move. We don't have much time, but I just want us to start the next lesson. Although it's a short one, so it won't really take us much time. So we've done the first one, we'll move to the second one. So the second one is we're now starting our data management process. So we're going to be looking at data exploration. So our objectives are that we would appreciate the aim of exploration in data management. We'll identify R codes for the R functions in data exploration. We'll list and explain the role of the R functions in exploration of data. We'll apply a few of their both functions, and if we have some time, we'll do some quiz. Okay, so let me share my screen. Okay, so number one, data exploration. So what do I mean by data exploration? Usually, once you have the data, most people will want to just run into it and begin to analyze, but that is not best practice. Best practice is once you get data, you want to exploit, you want to look through the data, understand the parameters of that data, understand what exactly data is talking about, understand the dimensions of that data and stuff. That is the first best practice of data management. And there are functions that we use to explore data. And I'm going to list a few of them. There are so many of them, but we'll list the most common ones. So the first one I usually use is dimension. Dimension, and the short form of the function is called DIM, that's dim, a short form for dimension. So dimension gives you the dimension of that data set. It tells you how many variables it has and how many rows. It tells you number of rows and columns, or number of variables and observations. So in this training, I'm going to be using those two words interchangeably. I can say variable or column, and then I can say observation or row. So those are interchangeable. So variable, I can interchange that with column. Observation, I can interchange that with row. So yeah, so dimension gives us the dimension, that's the number of rows and columns of that data set. We have class. So class tells us the class of particular variables. Broadly, we have two categories of classes of variables in data management. We have the numerical data and we have the categorical data. In R has like 5 thereabout classes of data. It has what we call the character class, which is a categorical variable. It has what we call the logical class, and logical class is when you have data where the responses are in twos, either yes or no, or male or female, or 1 and 0. So R calls that kind of variable as having a logical class. It also have numerical class. In R, there are 2 types of numerical class. You have what we call the double, in which case that numerical variable has decimals. For example, when you're dealing with heights, where you have 1.5 meters, 1.8 meters, R calls that a double. It's a numerical variable, but R calls it a double, DBL. And that's because it has decimals in it. It also has another type of numerical variable which does not have decimals, that are whole numbers. So that's another class of variables in R. I can't remember exactly what it's called, but we'll get to that. Then finally, it has what we call factors. Factors is also a categorical variable, just that the difference between factors and character is that in factors, you have levels. For example, when you're talking about the variable of marital status, where you have levels such as single, married, divorced, widowed. So you have levels. R calls them factors. So those are the 5 classes of variables R has. We'll see that as we proceed. Another function that we can use for data exploration is what we call structure. So R gives us the structure of that data set. We also have what we call summary. So R gives us the summary of that data set. We also have what we call glimpse. So R gives us a glimpse of the data set. We also have what we call scheme. So R gives us this. We also have unique. Unique just gives us the unique values within a particular variable. For example, if we're dealing with the variable marital status, even if there are 100 people that we're assessing, all of them will be grouped into unique variables, unique values of either single, married, divorced, widowed. So when you use unique, R will look at that variable and just bring out the unique values. So even if you have 20 single people, 30 married people, R will just say it has single, it has married, it has divorced, it has, so unique tells you the unique values within each particular variable. What else do we have? Unique, we have, okay, head. Head is a useful one. Head, if you use head for a data set, R tells you, just gives you a list of the first 6 observations in that data set so that you can begin to understand how your data set is. So it gives you the list of the first 6 variables. Its counterpart tail gives you a list of the last 6 variables within that data set. We also have, what else now? Okay, as we're going ahead, as I remember, we'll list them. So these are the most common functions that you use to explore data. So let's look at them individually. So if I say DIM, so let's use a data set that is within R already. I forgot to use view. View is also another one. View gives you a tabular representation of that data set. So let's assume there's a data set I mentioned before in R we call Star Wars. So if I say view Star Wars and I click Control Enter, so it gives us a tabular representation of the data set like that. So it shows us the data set in a table form like this. It tells us what the variable names are, the values, and what have you. So that's view. So we'll go back to our script. If we use DIM, that's dimension, and we do Star Wars, Control Enter. If you look at the console, this is the code dim Star Wars, and then 8714. So here R is telling us there are 87 rows and 14 columns. The first number is usually the rows of that data set. So we already know that that is the dimension of Star Wars data set. It has 87 rows and 14 columns. Okay, if we look at the data set itself, we can see if we count these variable names, there are 14 of them. Also, under here, this place where my cursor is, we can see the same information. It said showing 1 to 9 of 87 entries, which are the observations, and then 14 total columns, which are the variables. So if I count it, name is number 1, height 2, mass 3, hair color 4. If I count down to the end, there are actually 14 columns on this data set. Okay. If we use class, so because class works on a particular variable, we need to specify the particular variable once. So if I say Star Wars, this is the entire data set. So I have to specify to R which particular variable I want to know the class. So we use $sign here to subset and say, okay, we're talking about this variable. So if as soon as I typed this $sign, R now gives me a list of the variable names in that Star Wars data set. So I can choose, let's say I choose height, and then Control Enter. So it tells me that the class of height is an integer. So you remember I mentioned the two numerical variables. One is an integer, that's the one that has whole numbers, and the one that has decimals is called a double. So if I do the same thing again and say class, this session will end in less than a minute. We're supposed to